Let's look at another problem. Let's look at B. Let's look at -4, which is going to be our first term, our a sub 1. And notice they don't give us our common difference D. They give us the fifth term, which is going to be equal to 16. So we have our first term, and we have our fifth term. Notice in between we're missing a bunch of terms. We're missing A2. We're missing A2, A3, and A4. Now what's done in between those steps is each time we add the common difference D, whether that's positive or negative. That means you end up, through all of those, adding a D 4 times. So you've added D 4 times if you go from the A1 to the A5. So let's figure out what that common difference D is. Well, what is the gap of numbers? Well, we went from the beginning to the end, from the -4 to the 16. Well, we went from -4 and we went all the way up to 16, a positive 16. So we went from -4 to 0, and then we went from 0 to 16 basically, which is we added a total of 20. Well, when we go over from -4 to 20 and we cover, -4 to 16, and we cover those 20 values, that is split up evenly between our D's 4 times. So I can set this up as an equation that these 20 values should be covered by our 4 D's that all need to be the same. So if you set that up as an equation, we can just solve it normally by dividing both sides by 4. So we can divide both sides by 4, which gives us that the common difference D actually needs to be equal to 5, which makes sense. If we add 5 the first time, we'll just get 1. Adding 5 again will get us 6. Adding 5 again will get us 11. And adding 5 does get us the final answer of 16 for the fifth term. So now that we have our common difference D and we have our first term, that's all we need to find out any other terms that we need. So to find out the eighth term, first of all, remember we take the first term, which was -4, and actually take n minus 1, which is 7, times our common difference D, which we said was 5. So the 7 times 5 will give us 35 here. And then added to that first term, that was our -4, that gives us a value of 31. That's our eighth value. Or backtracking, we could have just gone to our fifth value and just kept adding 5 until we get to the eighth. We could have just kept on with our pattern. Either way. But there is no other way to find out what the nth number of our sequence is going to be. We have to use our formula, which says to find the nth value of our sequence, just like before, you start out with the first value, which was a -4. Then you multiply an n minus 1. You're not going to be filling in anything for n this time. Times a d. Well, we find out that d was 5. The only thing mathematically that you can do is multiply out that 5 here, that d, to your n minus 1, which will get you 5n minus 5. Then you do have some like terms you can combine. You've got a -4 and a -5, which gives you -9. So we end up with 5n minus 9 is going to be our nth term. And we end up with our eighth term was 31, and we are done. Let's look at problem C.